water, ammonia, HCl, methanol. Water, ammonia, HCl, methanol. Such reactions are called as what? Condensation reaction. Aldehyde or ketone reacts with phenyl hydrazine. Here also you remove H2O. It will form phenyl hydrazone. Saline solution is an alkaline copper sulfate solution containing sodium potassium tartarate. Sodium potassium tartarate is also called a Rochelle salt. Hello my dear students, I am Renuka Ashok, the Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Welcome to third session of chapter Aldehyde, Ketones and Carboxylic Acid. The third session of chapter Aldehydes, Ketones and Carboxylic Acid. In the previous session, I discussed about preparation of ketone, physical properties as well as what? Chemical properties. I discussed about preparation of ketones as well as its physical as well as what? Chemical properties. In this session, I am going to discuss about some of the special chemical properties of aldehydes and ketones like oxidation of methyl ketone, reaction due to alpha hydrogen, aldol condensation, cross aldol condensation, Cannizzaro reaction, electrophilic substitution reaction. Finally, I am going to explain what are the uses of aldehydes and ketones. In this session, I am going to deal with special reactions of aldehydes and ketones like aldol condensation, Cannizzaro reaction, as well as the reaction due to alpha hydrogen in case of aldol condensation, cross aldol condensation, electrophilic substitution. Okay. Now, the first one, I am going to deal with condensation reaction with derivatives of ammonia. Aldehyde and ketones undergo condensation reaction with ammonia and its derivatives. Ammonia and its derivative. Ammonia means NH3, its derivatives means amines, NH2 group. So, aldehydes and ketones undergo condensation reaction with ammonia and its derivatives. What is condensation reaction? Condensation reaction is a chemical reaction where there is an elimination of simple molecules like water, ammonia, HCl, methanol. Water, ammonia, HCl, methanol. Such reactions are called as what? Condensation reaction. Here, in case of this condensation reaction, the CO group is replaced by CNZ group, CNZ group. And this reaction is reversible and it is catalyzed by acid, Therefore, ammonia and the derivatives of ammonia react with carbonyl group of aldehydes and ketones to form condensation products. First one, reaction with hydroxylamine. The formula of hydroxylamine is H2NOH. What's the formula of hydroxylamine? The formula of hydroxylamine is H2NOH. Aldehyde and ketones reacts with hydroxylamine in the presence of acid catalyst. They'll form oximes. What are oximes? Oximes are a class of organic compound having general formula RR-CNOH obtained by treating aldehyde and ketones with hydroxylamine. If I consider this as a general formula of both aldehydes and ketone, if I won't take H, it will become ketone. If I take R-, it will become ketone. If you won't take R-, it will become aldehyde. Remove water here, okay? Oxygen atom of carbonyl group and H2 of hydroxylamine combine to form water and there is a formation of oxime, The general formula of oxime is R-C-R- double bond NOH, What's the product form? When aldehydes and ketones are heated with hydroxylamine. When aldehydes and ketones are heated with hydroxylamine, there is a formation of oxime. Example, you take formaldehyde. So, in whether it is aldehyde and ketone, the common group is carbonyl group, C double bond O. If both the valencies are satisfied by hydrogen, it is known as formaldehyde. When formaldehyde is heated with hydroxylamine in the presence of acid catalyst, it will form formaldehyde. So, next to reaction with hydrazine. Hydrazine is H2NNH2. Aldehyde or ketone treated with hydrazine. Here also eliminate water. It will form hydrazone. What happens when it reacts with hydrazine? When aldehydes and ketones are heated with hydrazine, they will form respective hydrazone. Similarly, example, you take formaldehyde. Here you eliminate water. You will get formaldehyde hydrazone. Third one, phenylhydrazine. Phenylhydrazine. The formula of phenylhydrazine is H2N NHC6H5. NHC6H5. Aldehyde or ketone reacts with phenylhydrazine. Here also you remove H2O. It will form phenylhydrazone. Phenylhydrazone. Once again I have given example of formaldehyde. What's the structure of formaldehyde? HC double bond OH, H2N NHC6H5. Here you eliminate water, you will get formaldehyde phenylhydrazole. When it treated with hydroxylamine, what's the product form? The product form is oxime. When it is heated with hydrazine, the product form is hydrazone. When it is heated with phenylhydrazine, the product formed is phenylhydrazole. Next, it is treated with 2,4 dinitrophenylhydrazine. 2,4 dinitrophenylhydrazine. So when the place in the benzene in second and fourth position you put nitro group as well as H2N NH2 and you write general formula of aldehyde and ketone that eliminate water. When you eliminate water, you will get 2,4 dinitrophenylhydrazone. This is phenylhydrazine. It is phenylhydrazone. It is also called as Brady's reagent. It is called as what? Brady's reagent, or it is called as 2,4-DNP. 2,4-DNP. The 2,4 dinitrophenylhydrazone. 2,4 dinitrophenylhydrazone is also called as Brady's reagent or 2,4-DNP. It has red color, yellow color, or orange color. Once again, you have to take an example of formaldehyde. In that you eliminate water, will get formaldehyde 2,4 dinitrophenylhydrazone. This is the reaction, condensation reaction. Next, Clemmensen reduction. In Clemmensen reduction, what's the mechanism? CO group is reduced to CH2. Here, my dear student, don't change alkyl group. Don't change alkyl group. Convert CO into CH2. CO into CH2. When you convert CO into CH2, the product obtained is hydrocarbon. Product obtained is hydrocarbon. The reducing agent used in case of Clemmensen reduction is zinc amalgam and concentrated HCl. What's the reducing agent used in Clemmensen reduction? The reducing agent used in Clemmensen reduction is zinc amalgam and concentrated HCl. What's the reducing agent used in Stephen reduction? Stannous chloride and concentrated HCl. What's the reducing agent used in Clemmensen reduction? Same concentrated HCl, but instead of stannous chloride, we have to use zinc amalgam and concentrated HCl. What's the mechanism in case of Clemmensen reduction? Here don't touch whether it is alkyl group or aryl group. Only you convert CO group into CH2. CO group into CH2. For example, if I consider CO is converted into CH2. CH2 take this HH and it will form CH4. Like what's the final product during Clemmensen reduction? The final product during Clemmensen reduction is hydrocarbon. Next, Wolff-Kishner reduction. Wolff-Kishner reduction. In case of Wolff-Kishner reduction, aldehyde or ketone is heated with hydrazine. Heated with hydrazine. You already know that when it is heated with hydrazine, it will form hydrazone. It will form hydrazone. It is heated with KOH and ethylene glycol. It is heated with KOH and ethylene glycol. There is a liberation of nitrogen and there is a formation of hydrocarbon. Similarly, in case of Wolff-Kishner reduction also, the aldehyde or ketones are reduced to hydrocarbon. But what is the one difference between Clemmensen reduction as well as Wolff-Kishner reduction? In case of Clemmensen reduction, the reducing agent used is zinc amalgam and concentrated HCl. But in case of Wolff-Kishner reduction, the reducing agent used is hydrazine. Then it will form hydrazone. That hydrazone is heated with KOH in ethylene glycol. But what's the mechanism in case of Wolff-Kishner reduction? In Wolff-Kishner reduction also, CO group is reduced to CH2 group. CO group is reduced to CH2 group. Next, tolerance test as well as what? Fehling's test. Tolerance test as well as what? Fehling's test. These are tests used to distinguish between aldehydes and ketone. Aldehydes and ketones are distinguished by using two tests. One is tolerance test as well as Fehling's test. In case of tolerance test, we are using tolerance reagent. You are using tolerance reagent. What is tolerance reagent? Tolerance reagent is ammonical silver nitrate. Tolerance reagent is ammonical silver nitrate. Ammonical silver nitrate. reagent. What happens when aldehydes are heated with tolerance reagent? You will get a black precipitate of silver or shining silver mirror or shining silver mirror. Aldehyde is heated with tolerance reagent, you will get silver mirror. You will get silver mirror. This reaction is not answered by ketone. Therefore, if you want to distinguish between aldehyde and ketone, both are heated with tolerance reagent. If you get black precipitate or shining silver mirror, it is aldehyde. If you won't get any black precipitate or shining silver mirror, it is ketone. This is one of the tests which is used to distinguish between aldehyde and ketone. And this tolerance test is also called as silver mirror test. It is also called as silver mirror test. It is also called as silver mirror test. Next to Fehling solution. What is Fehling solution? Fehling solution is an alkaline solution of copper sulfate containing sodium potassium tartarate. What is Fehling solution? Fehling solution is an alkaline copper sulfate solution containing sodium potassium tartarate. Sodium potassium tartarate is also called as Rochelle salt. Also called as Rochelle salt. When it is heated with aldehyde or heated with Fehling solution, you will get red precipitate. You will get red precipitate. Ketones does not answer Fehling's test, as well as the very important thing is aromatic aldehyde do not answer Fehling's test. Therefore, all aldehyde answers tolerance test, but aromatic aldehyde does not answer Fehling's test. Does not answer Fehling's test. Like, what's the endpoint in case of tolerance test? Tolerance test, the endpoint is black PPT. In Fehling's test, the endpoint is red PPT. Then aldehyde and ketone has also undergo haloform reaction. But this reaction is not answered by all aldehydes and ketone. This is answered only by that aldehydes and ketones which containing at least one methyl group which is attached to carbonyl group. When they are heated with sodium hypohalide, they are converted into sodium salt of carboxylic acid. If it contains n number of carbon atom, it has n minus 1 number of carbon atom. And here also there is a formation of haloform. Methyl group is converted into haloform. Therefore, this reaction is called as what? Haloform reaction. Next to reaction due to alpha hydrogen. What is alpha hydrogen? It is a functional group aldehyde. Here, which is functional group? Ketone. The carbon which is directly attached to the functional group, it is known as alpha carbon. The hydrogen which are attached to the alpha carbon, they are called as alpha hydrogen. See, my dear student, where I am rounded this hydrogen atom, they are alpha. Here 3 alpha, here 6 alpha. Acetaldehyde, ethanol contain 3 alpha, acetone contain 6 alpha. Those containing alpha hydrogen, they undergo aldol condensation. So what is aldol condensation? Now I'll consider aldol condensation. Aldehyde and ketones which containing at least one alpha hydrogen. So what's the criteria? What's the condition for aldehyde and ketone which undergo aldol condensation andre adralli ಒಂದು alpha hydrogen ಇರಬೇಕು. ಏನು alpha hydrogen ಅಂದ್ರೆ hydrogen atoms which are attached to the alpha carbon. Alpha carbon ಅಂದ್ರೆ ಏನು ಮಕ್ಕಳೇ? Carbon atom which is directly attached to the functional group. So that is heated with dilute alkali. First it will form aldol or ketol. What are aldol? Aldol are beta hydroxyaldehyde. Ketol is beta hydroxy ketone. So this aldol which is formed by losing water, it will form alpha beta unsaturated compound. They'll form alpha beta unsaturated compound. So for aldehyde I had taken acetaldehyde, for ketone has taken acetone. It will form acetaldol, it will form ketol. When they are heated, they will form alpha beta unsaturated compound. They will form. Okay. Next, if it contain cross aldol condensation, if aldol condensation takes place between to similar molecules of aldehydes and aldol condensation is not confined to similar molecules of aldehydes and ketone. Different aldehydes and different ketones, when they react, it is called as what? Cross aldol condensation. On the board, it is a cross aldol condensation between acetaldehyde and propanaldehyde. Acetaldehyde and what? Propanaldehyde. It will give rise to how many products? 4 products. It gives rise to 4 products. Okay. Next, Cannizzaro reaction. Aldehyde which do not containing alpha hydrogen, when they treated with strong alkali, they undergo reduction and oxidation form One reduced to primary alcohol, another one is oxidized to sodium or potassium salt of carboxylic acid. That reaction is called as what? Cannizzaro reaction. Aromatic aldehydes undergo electrophilic substitution, nitration. The meta position is substituted by nitro group. Meta position is substituted by nitro group. Okay. So now what are the uses of aldehydes and ketone? In chemical industry, aldehyde and ketones are used as solvent as well as synthesis of other products. Butyraldehyde, vanillin, acetophenone, camphor are well known for their odor and flavor. The commercially important carbonyl compounds methanol, ethanol, benzaldehyde and propanone. Okay. So these are the list of uses of formaldehyde. Formaldehyde used in bakelite, resins and polymers. 40% solution of formaldehyde is known as formalin. Formaldehyde is used in the preparation of urotropin, a urinary antiseptic. It is used as an antiseptic. Ethanol is used in the preparation of number of organic compounds like acetic acid, ethyl acetate, N-butyl alcohol. Paraldehyde is a polymer of acetaldehyde used in medicine as hypnotic. It is used in silvering of mirrors. Acetone used as solvent. Ingredient in nail polish, stony acetylene gas. Benzaldehyde, perfume industry, dyes like malachite green as well as organic compounds like benzyl chloride as well as what? Cinnamic acid. These are the uses of formaldehyde, acetaldehyde, benzaldehyde and acetone. My dear student, next class I'll come up with a new family, that is carboxylic acids. Next session is carboxylic acid. Until that, goodbye. Have a nice day. Take care. Thank you, my dear students.